so this first one is called a linear function. So it says f of x equals x. So when you see these equations, so we have the name of the equation or the name of the function, and then what its parent function, most basic equation can be written. Right? So the name and then the parent function. So f of x equals x. So that's the same as y equals x. So remember the other day when we talked about what a function is, f of x is the same as y. So y equals x is the equation. So if we want to graph that to see what it looks like, well, we can make an xy table and we can plot some points. And so in our xy table, you can pick, any x values you want. Okay, so let's say I use -2, -1, 0, 1, and 2. And so with those x values, I plug them in for x and find the y values. All right, so if I take -2, plug it in for x, I get y equals -2. So the y coordinate is -2 when x is -2. And then I can do the same for the rest of them. So when I plug -1 in for x, I get -1 in for y. Okay, plug 0 in, I get 0. 1, I get 1. 2, I get 2. Now I can plot those 5 points, and I can kind of see what the shape of this function looks like. So -2, -2, -1, -1, 0, 0, 1, 1, and 2, 2. Right, so from those 5 points, we can see the shape of what this graph is going to look like, and it's a line. Goes up on the right, down on the left. So when we think linear function line, the shape that we always want to think of is that right there. That's the shape of a linear function. And that's its most basic function. All right, what would the domain of this function be? Or the domain of the graph? Okay, see, look at it on the graph. Yes? Good, -infinity to +infinity. Brooklyn, Stevenson? Brooklyn? Okay. Say what's for. Go ahead and take it with you. All right, what would the range be? Good, -infinity to +infinity. All right, x-intercept is where the graph crosses the x-axis. So what would that be on this problem? 0, good. And the y-intercept? 0. Okay, perfect. All right, next one is the quadratic function. A quadratic function. So that's f of x equals x squared, or y equals x squared. So it makes it a little bit easier. All right, so here again, we're going to go ahead and graph it. Make an xy table. All right, so again, I could just use -2, -1, 0, 1, and 2. I'm going to plug those x values in and square them. So remember, when we substitute a number in for a variable, we got to think parentheses, because that exponent's on the outside of the parentheses. Okay, if you don't put parentheses and you're just using the calculator, a lot of times the calculator's not going to see it that way. So when you put -2 in for x and square it, it's -2 times -2, which is +4. All right, and then we plug -1 in and square it, we get +1. Plug 0 in, we get 0. Plug 1 in, we get 1. Plug 2 in, we get 4. All right, and then we can plot those 5 points to see the shape of this graph. All right, so -2, 4, -1, 1, 0, 0, 1, 1, and then 2, 4. All right, so when we connect these dots, a quadratic function has the shape of a U. All right, it's a U, not a point, not a V, it's a U. So the shape we always want to think of, anytime we see x squared or we see the name quadratic has a U shape for the graph. All right, what would the domain be for this function? Yeah. Yeah, negative infinity to positive infinity. How about the range? Good, 0 to positive infinity, and 0 is going to have a bracket. X-intercept. Where's the graph cross the x-axis? 0. How about the y-intercept? 0 also. All right, so the next function is the square root function. So you can see f of x equals the square root of x. Okay, or y equals the square root of x. Square root function has to have a square root in it. All right, so let's go ahead and do our table. All right, so when we put negative 2 in for x and take the square root of it, that'll get us our y value. All right, so if we try to put negative 2 in, and you can check it on your calculator, it doesn't exist. You get an error message. You can't take the square root of negative 2. So there is no y value. Same if we try to put negative 1 in for x. There is no square root of negative 1. It doesn't exist. So you can't use negative 1. Now 0 we can plug in. What's the square root of 0? 0. Okay, you have calculators. It'll tell you all this stuff. Okay, I'm not asking you to memorize it all. Okay, so you should have calculators. You know how to find your square root key. Okay, so square root of 0 is 0. How about 1? Square root of 1 is 1. Yeah. Now 2, if we try to do the square root of 2, we're going to get some decimal. Okay, so on the square root function, we don't want to use 4 or 2, and we don't want to use 3, but we do want to use 4. All right, because we can take the square root of 4. Hopefully you don't need a calculator for that. What's the square root of 4? 2, yeah. All right. So really, these are the 3 we want to use on the square root function. You don't want negatives, but you do want 0. You do want 1. You do want 4. Now, you can put another one in there if you want. 9 would work nice. Okay, 9, square root of 9 is 3. So 9, 3. Okay, so if we plot these points, 0, 0, 1, 1, and then 4, 2. 1, 2, 3, 4, 2. All right, so this is what the shape looks like. So it's kind of like a ray. Okay, it has an endpoint and an arrow going off in the other direction, but it's a curve. It's not a straight line ray. It has a curve to it. So the shape, kind of think of it like that. All right, so square root has an endpoint. So that's our starting point. Starts at 0, 0, and then goes off and to the right. So anytime you have to graph the square root function, use 0, 0, 1, 1, 4, 2. Okay, those are your 3 points. And again, you could use 9, 3 if you want to also. Okay, what would the domain of this function be? Yes? Good, 0 to infinity, and we're going to use a bracket. All right, and then the range? Yes? Yeah, it's the same, 0 to infinity. Good. So trying to think on the square root function, it doesn't go horizontal. Like, it's not going horizontal. It's actually going up at an angle, which is really slow. So it is continuing to go up to positive. What would the x-intercept be? 0. Y-intercept? 0. Okay. So you can see a lot of these use 0 and 0 for both x and y as the starting point. Okay, in there. All right, absolute value function. All right, so -2, -1, 0, 1, 2. All right, so what's the absolute value of -2? 2. Remember, when we plug a number in inside the absolute value, all it does is make it positive. All right, absolute value -1, 1, absolute value 0, 0, absolute value of 1, 1, absolute value 2, 2. All right, so let's plot those. So -2, +2, -1, 1, 0, 0, 1, 1, 2, 2. So this is similar to the quadratic, okay? But it has the shape of a V. So that's two rays that are straight lines, okay? So it comes to a V, a point, instead of a U. So the shape that we want to think absolute value, think of the V for absolute value. So I'm showing you how to use an XY table because if you understand, you know, if you forgot how to do the shape or what it even looks like, you can always make an XY table and plot points, and then from those points, the shape should start to materialize what it looks like. What's the domain? Okay. Range? Yeah, it's 0 to infinity. X-intercept? 0. Y-intercept? 0. All right, cubic function. So cubic has a x to the third. All right, so again, we could use -2, -1, 0, 1, 2. All right, so here we're plugging -2 in for x and cubing it. We're multiplying it by itself 3 times. So what's -2 to the third power? Good, -8. -2 times -2 times -2, -8. -1 cubed, -1. 0 cubed, 0. 1 cubed, 1. And 2 cubed, 8. All right, let's plot those. -2, -8. It's down here. -1, -1, 0, 0, 1, 1, 2, +8. It's up there. All right, so the shape of a cubic, or x to the third, is, think of an S. Right, so here's our shape. So it's going to go up on the right and down on the left. It's going to go through 0, 0. All right, now these arrows for each side is not going straight vertical, it's going out at an angle. So it's really slow on both sides. So it's not going vertical. All right, what would the domain be? Good, -infinity to +infinity. Range, same. X-intercept, 0. Y-intercept, 0. All right, the cube root function, cube root. Okay, that's different than the square root function. This has a little 3. See a little 3 here that means cube root. Not cubic, but one above it. Cube and root. All right. So let's go ahead and plot some of these points. All right, so the cube root function It's a little different than the square root. Square roots, you can't put negatives underneath the radical, but cube roots you can. All right, so you can take the cube root of a negative number. Your calculator will actually calculate it for you. You just have to find your cube root key on your calculator. All right, so when we do cube root, the ones that I would use, we want perfect cubes, and you would see it from above on the cubic function, which ones are the cubes. So in the cubic one, I would use -8, -1, 0, +1, and +8. Okay, those are all perfect cubes. Because there's a number that multiplies by itself 3 times that equals that number. All right, so again, if you're not sure, either find this key on your calculator, or you have this key on your calculator. One of those two. If you're using this key, all it's saying is you have to plug a 3 in your calculator so you can use that key. So it knows you want the cube root. So you put 3, punch in 3, then get to that key right there, and it's going to put the 3 there for the cube root, and then you can put any number you want underneath, and then hit equals. Right? So you should try it on your calculator with the cube root. If you have this key, punch in 3, hit this key, then try -8, and then hit equals. If you have this key that you're using, again, it depends on the order. You either hit this key first, then -8, or you hit -8 first, then you hit this. But it knows it's cubing or cube rooting the -8. Okay, so you should try both, but you should get -2. All right, -2 times -2 times -2 is -8. All right, and then we can do the cube root of -1. All right, and that's -1. Because -1 times -1 times -1 is -1. Cube root of 0 is 0. Cube root of +1 is 1, and the cube root of 8 is +2. So when you're doing cube roots, if you don't use those x values and use other numbers, let's say you use 2 or 3 or 4, you're going to get a decimal. All right, and so it's easier to do this without decimals, if you can help it. All right, so let's go ahead and plot these points so we can see the shape. -8, -2. 1, 2, 3, 4, 5, 6, 7, 8, -2. It's down here. -1, -1. 0, 0, 1, 1. And then +8, +2. 1, 2. Okay. All right, so this is what the shape looks like. It's kind of like an S, but it's going sideways instead of vertical like the cube root did. So it's going to run horizontally instead of vertically. Also, we can kind of see the shape. Like if this half wasn't there, it's kind of similar to the square root function. Okay, the square root function looks like that, and then the cube root comes out of front. All right, so here's our shape. All right, so the domain looks like -infinity to +infinity. The range is going to be the same. X-intercept, Y-intercept, both 0. All right, and then these other two functions, I'm just going to talk really briefly about them because we have a whole unit that's going to talk about these and graph these later on. So the first one's exponential functions. This was done in Algebra 1, exponential functions. So this b value can be any number that's greater than 0, has to be a positive number, can be a fraction. It just can't be 1 though. Right, so any number. So its shape is going to look like this. I'll just put it on the graph. Right, so that's what we're going to get into later on. I think that comes in next semester, exponentials. Right, so that's what the shape looks like. And then the second, and this other one is rational functions. So rational functions have a variable x in the denominator, not in the numerator. Okay, so it's in the denominator. So anytime we have x in the denominator, it's a rational function. And the shape of a rational function for the parent function is going to look like this. We get 2 curves, and they're going to be in diagonal quadrants of each other. So they never cross the x-axis, and they never cross the y-axis. Okay, so that's rational function. So those are your 8 functions. All right, so now let's go through each of these and answer the question. It says, given each of the following equations, identify the name of the parent function and then give the parent function equation. All right, so we'll give the name of it first. So number 1, since there's a square root in it, we call this a square root function. All right, so once you know the name, then you can kind of just look back in your notes what the parent function is. Well, the parent function equation, we could just write y equals square root x. That's the parent function. Or you could write f of x equals square root x. All right, so there's all these other numbers that they're going to throw into the equation, and we're going to look at that stuff and what it does to from the parent function, what does it do to it, starting tomorrow. But right now, we just have to know what the name is and what's the basic parent function equation. All right, so number 2, what's that called? Absolute value. All right, and its parent function equation, y equals absolute value x. All right, number 3, since there's an x in the exponent, this is called exponential function. And its parent function for this specific problem would be y equals 3 to the x power. So that b value in the parent function just gets replaced with a number, and we use 3 as that b value instead. So it has to be a number that's bigger than 0, but not 1. So this number right here acts as like b. All right, number 4, we have an x squared, and so that's a quadratic. And its parent function, y equals x squared. All right, number 5, there's an x in the exponent, so this is exponential again. And its parent function would be y equals 4 to the x. So the number that's next to the exponent is your base number, they call it. All right, number 6, this has a cubic, okay, x to the third. So this is a cubic function. Parent function, y equals x to the third. Again, strip off all the numbers and just look at where the variable is. Is there an exponent? Is there a radical? Is there an absolute value? All right, number 7. What do you think this one's called? Yeah, linear. Yeah, this is linear. Okay, a linear function. And so y equals x. All right, number 8. What's this one called? A rational. Yeah, because the x is in the denominator of a fraction, so it's called rational. It's a rational function. Its parent function, y equals 1 over x. All right, number 9, we have a radical with a little 3, so this is a cube root function. So y equals cube root x. And last one, number 10, what's this one called? Linear. Yeah, it looks like it'd be rational because of the fraction, but the x is not in the denominator. It can actually be moved up into the numerator. 1 over 3x is the same as x over 3. So this is linear. All right, so real quick, what I want you to do is next to each one of these, 1 through 10, I want you to just draw the shape. Okay, draw the shape of each one of these functions next to it. Okay, so you should be able to do it real quick.